Today's topic: particle in two-dimensional and three-dimensional box and degree of degeneration.
Hi friends, once again on my YouTube channel. In previous class, we discussed the wave function and the energy of the particle in one-dimensional box. We have seen that the wave function of the particle in 1D box is given by psi is equal to root 2 by L sine n pi x by L. Today my topic is particle in two-dimensional box. In this class we can determine the wave function and energy of the particle in two-dimensional box. Let us consider a particle of mass m moving in two-dimensional box having side A and B along the x and y axis respectively. The potential energy of the particle inside the box is 0, whereas the potential energy at the boundary and outside the box is infinity. Now the wave function of the particle in two-dimensional box is depend on the coordinate. Therefore, the wave function of the particle in two-dimensional box is the product of psi x and psi y. So the value of psi x is root 2a sine nx pi x a, and the value of psi y root 2b sine ny pi y b. Now the total wave function psi equal to 2 root of ab sine nx pi x a sine ny pi y b. If we consider the box is square, then a equal to b. Then the wave function is given by a equal to a, so square root of a square, that means a. So psi equal to 2 by a sine nx pi x a, as a equal to b, so sine ny pi y by b. This is the wave function of the particle in two-dimensional box if the box length a equal to b. Now we will determine the energy of the particle in two-dimensional box. So what is the energy of the particle? The energy E nx ny, where nx ny is the quantum number. Nx is the quantum number along x-axis and ny is a quantum number along y-axis. The value of nx ny are 1, 2, 3 respectively. And here A is the side length along x-axis and B is the side length along y-axis. It's very simple, already they discussed in previous class. Now the energy of the particle in two-dimensional box is given by E nx ny is equal to Ex Ey. That means E nx plus E ny. Now what is the value of the energy? Already we discussed in previous class the energy of the particle in one-dimensional box is given by En is equal to n square h square by 8m l square, where L is the box length of the particle in one-dimensional box. Here the energy is nx square h square. Nx is equal to quantum number along x-axis. So nx square h square 8m a square, a is the box length along x-axis, and ny square h square 8m b square, here b is the box length and ny is the quantum number along y-axis. Now if the box length a equal to b, that is the box is square, then the energy of the particle in two-dimensional box is given by h square 8m a square, because a equal to b, nx square plus ny square. Now we will calculate the 0 point energy. So 0 point energy, the value of nx and ny equal to 1, and so the E11 putting the value of nx is equal to 1 and ny is equal to 1, then the energy is h square 8m square 1 square plus 1 square, that means that 2h square 8m square, that is the h square by 4m square. This energy is called the 0 point energy. This is the minimum energy of the particle in two-dimensional box. This is a ground level. But in case of fast excited level means this is level is basically E1 level, and fast excited level means the level is E2. In E2 level, the one quantum number is mainly 2 and another quantum number is 1, and so in energy level E2 level, that is the fast excited level, that is the E12 means nx equal to 1 and ny equal to 2, then the value of the energy is 5h square 8m square, whereas the nx value is 2 and ny is equal to 1, and this is also the fast excited energy level. So the fast excited energy level, two levels are obtained. One is E12 and another is E21, and so the energy is same, h square 8m square 5h square 8m square, and so these two energy levels E12 and E21 levels are degenerate. The two energy levels E12 and E21 level having the same energy, and this energy level the energy level of E12 and E21 are degenerate. So now the question is arise, what is the degeneracy? What is the degeneracy and what is the degenerate energy level? The different level but having the same energy. What can I say? The different level but having the same energy is called the degenerate state. And number of such energy levels are called degree of degeneracy of the degenerate of state. Okay, so in two-dimensional box, fast excited energy level having degeneracy 2. What is the degeneracy value? The E12 and E21, the two degeneracy level. And what is the value of the energy of the fast excited state in particle in 2D box? So this is the energy level. The energy value is 5h square 8m square. Okay, now we will discuss the particle in three-dimensional and wave function of the particle in three-dimensional box. Let us consider a particle for mass m having moving in three-dimensional box having side length a, b and c along x, y and z axis respectively. The potential energy of the particle within the box is 0, while the potential energy at the boundaries and outside the box is infinity. Now the wave function of the particle is depend on the coordinates. That is, the wave function of the particle in three-dimensional box is the product of psi x, psi y and psi z. So the wave function of the particle psi equal to the value of psi x equal to root 2a psi nx pi xa. Already we discussed the nx, ny and nz is a quantum number, and so the psi y is equal to root 2b sin ny pi by b and psi z equal to root 2c sin nz pi z c. If the box is cubical, that is a equal to b equal to c, so the value a is equal to so the value b is equal to a and also c is equal to a, that is box is cubical. The wave function of the particle in three-dimensional box is given by psi equal to 2 root 2a sin by calculation sin nx pi xa into sin ny pi ya and sin nz pi z a. Now we'll determine the energy of the particle in three-dimensional box. Here we consider the box is cubical, and that's why A equal to B equal to C. Now the energy of the particle in three-dimensional box is given by Ex plus Ey plus Ez, and so and here A equal to B equal to C, and that's why h square by 8m a square, the value of A equal to B equal to C, nx square plus ny square plus nz square. Now in case of 0 point energy, so putting the value of nx equal to 1, ny equal to 1 and nz equal to 1, we have get 1 square, 1 square, 1 square, that is 3h square 8m square, and this energy, that is 3 into 0, this energy is called 0 point energy. And the energy of the first excited level is given by E11 is given by E112. First excited stable means one quantum number is 2, but another two quantum number is 1. It is remembered to that in case of first excited state, that is in case of E2 level, the one quantum number is 2, but others two quantum number is 1. So in this case, three energy levels are generated. What is the energy levels? The energy levels are E112, E121 and E211, and by calculate the energy in three level, we have seen that the energy value is 6h square 8m square, that means 6E0, that means 6E0, that means 6E0. So three energy levels are generated, three levels are generated, but having the same energy. The magnitude of energy is 6h square by 8m square. So three levels are generated but having the same energy. This energy is called degenerate. This level is called degenerate energy level, and degenerate energy level, and number of such energy levels are called degree of degeneracy. So in case of particle in three-dimensional box, in first excited level having degree of degeneracy equal to 3. So we repeat again 3, 2 on 1, 1 to 1 and 1 on 2. So degree of degeneracy is 3. That is, energy levels are different but having the same energy. So we conclude that the first excited state, that means E112, that is E2, arises when one quantum number becomes 2 and another two quantum number remaining 1. Thus, for E2, there are three possibilities. These possibilities are 112, E121 and E211. Now, the energy of each possibility will be identical, and it is given by 6E0. Similarly, the E3 level will also be deeply degenerate, denoted by this is the 221, 212 and 122, and each of which is having energy 9E0, and so on. In case of E4, it is again deeply degenerate, given by 311, 131 and 113 respectively. And this is the degree of degeneracy and degenerate energy level of the particle in three-dimensional box. Now we will discuss the distortion of the cubical box. The distortion of the cubical box and what will be happening, the degeneracy. It is very important. It is a very common experience in chemistry that on a side distortion of any direction, X, Y and Z, the electronic degeneracy of a system is removed and the energies of the new state are lowered down. Here the analogous phenomena John Taylor effect can be mentioned. So John Taylor effect in quantum chemistry is the quantum mechanical phenomena. According to this theorem, any nonlinear molecule system possessing degenerate electronic state will undergo a distortion, giving rise to a system of lower symmetry of lower energy, and the degeneracy will be removed. Thus, such a nonlinear molecule undergoes a distortion from its most symmetric configuration to attain a configuration of lower symmetry and lower energy. In the next class, we will discuss the importance of the model of the particle in 1D box and some application of the model of particle in one-dimensional box. Thank you.